Hypatia of Alexandria. From what we know, she was the first female mathematician. She was the daughter of Theon, a mathematician, astronomer, and a distinguished professor at the University of Alexandria. According to Yelena Zibrak, Theon tried to raise the perfect daughter. She was brilliant, athletic, and beautiful. There is little knowledge about Hypatia's mother, but it is assumed that her family situation must have been fortunate. She lived in the city of Alexandria, which is located in Egypt near the Mediterranean Sea. It was founded in 3030 BC by Alexander the Great. Greek was the main language. Alexandria contained the world's first center for learning. This was called the Library of Alexandria. According to Michael Deacon, Euclid was an early and probably the first professor of mathematics here. Theon of Alexandria was the last person definitely known to be associated with the museum. During this time, there were many political and religious issues. According to Deacon, in the years around 400 AD, Alexandria was a turbulent mix of cultures. Christians were in the majority, but they were divided among themselves. According to Dr. Finney Smith, there was the principle of doctrinal unity, which meant that everyone had to believe the same thing. There were also many riots during this time period. Hypatia was born between 350 and 375 AD. Dzalska and Deacon argue an earlier birth at around 355 AD, because she was thought to be older than her students. Hypatia was born in the later part of the Roman Empire, an era where women were not free to pursue careers. There are many portraits that portray what she might have looked like. She is commonly portrayed as a young woman facing the issues of a changing world. Many stories through the novels and movies are not based on firm evidence. According to Michael A.B. Deacon, the primary sources include the entry in the Suda lexicon. This was a 10th century encyclopedia comprised of a number of sources. A passage in the Ecclesiastical History of Socrates Scholasticus. Within this passage, it is said, "There was a woman at Alexandria named Hypatia, daughter of the philosopher Theon, who made such attainments in literature and science as to far surpass all the philosophers of her own time." Damascius and Socrates Scholasticus were alive during the time of Hypatia and wrote what has survived about Hypatia. Other ancient sources include Hypatia's pupil Synesius of Cyrene, who wrote a number of letters about Hypatia. There were also mathematical commentaries she made with her father Theon. Some people were not too fond of Hypatia and spread rumors about her. John, Bishop of Nicaea, said, "And in those days there appeared in Alexandria a female philosopher, a pagan named Hypatia, and she was devoted at all times to magic, astrolabes, and instruments of music, and she beguiled many people through satanic wiles." During her time, there was a switch from primary research to conservation and explanation. She was taught mathematics by her father Theon. Damascius stated, having a nobler nature than her father's, she was not satisfied with his mathematical instruction, but she also embraced the rest of philosophy with diligence. She was a famous teacher. She taught mathematics and Neoplatonist philosophy in Alexandria. She taught the philosophy of Neoplatonism, which meant the one truth. The idea of Neoplatonism was very intellectual, a little bit mystical, and sometimes ritualistic, and everybody's idea of Neoplatonism was a little bit different. And it consisted of 3 elements: unity, intelligence, and soul. Scholasticus states, "She explained the principles of philosophy to her listeners, many of whom came from a distance to hear her." One of Hypatia's famous quotes is, "Fables should be taught as fables, myths as myths, and miracles as poetic fantasies. To teach superstitions as truths is a most terrible thing. The child's mind accepts and believes them, and only through great pain and perhaps tragedy can he be in after years relieved of them." She was loved and honored by the city and would lecture publicly. According to many sources, she was very beautiful and attractive. One of the men that attended her lectures confessed his love for her, but she denied him and remained unwed. One pupil that worshipped her was named Synesius. He consulted her on many of his works and thought very highly of her. He referred to her in one of his letters as mother, sister, teacher, and withal benefactress, and whatsoever is honored in name and deed. He also states, "She is the one who legitimately presides over the mysteries of philosophy and my most revered teacher." Dzalska described the teaching of Hypatia, saying, "Around their teacher, these students formed a community based on Platonic system of thought and interpersonalities. They called the knowledge passed on to them by their divine guide mysteries. They held it secret, refusing to share it with people of lower social rank, whom they regarded as incapable of comprehending divine and cosmic matters." Overall, she was an amazing teacher. Many of her students went on to pursue high positions of authority, such as bishops and government positions. She also made long-lasting bonds with her students. She is quoted saying, "Reserve your right to think, for even to think wrongly is better than not to think at all." Some people consider Hypatia's story a Greek tragedy. She was most famous for a brutal murder at about 415 AD. Her death is generally accepted as March during Lent at 415 AD, although some argue 416 or 417 AD. According to Dr. Fanny Smith, during her last days there were many riots that broke out between Christians and pagans. There was a violent succession with 3 days of street fighting. At the time of Hypatia's death, the local governor was Orestes. In 415 AD, the authority of Orestes was under challenge from that of the less tolerant Cyril. Cyril was a young bishop of Alexandria and was appointed shortly before Orestes and planned to succeed the patriarchy. The city erupted in violence. Many of her works were destroyed. Deacon stated, "The great libraries associated with the museum were one by one destroyed, the last going up in smoke in 392 AD, when the temple of Serapis was put to the torch during the riot." Hypatia was considered a threat during this time because she was so well respected. Scholasticus mentions that many men dragged her away, took her to a church called Caesarium, where they stripped her and murdered her with tiles. They then took her mangled limbs and burnt them. The Suda states that she was torn to pieces by the Alexandrians, and her body was violated and scattered over the whole city. She suffered this because of envy and her exceptional wisdom, especially in regard to astronomy. Later on, Cyril was hailed New Theophilus, for he had destroyed the last remains of idolatry in the city. This means that he had destroyed everyone that was admired. He was also later declared a saint. After Hypatia's death, she naturally became more famous and admired. She might not have been remembered by others if she wasn't brutally murdered. Even though most of her work was destroyed, there is still some evidence of her contributions. According to the Suda, she wrote a commentary on Diophantus Arithmetica, the astronomical canon, and a commentary on the conics of Apollonius. Commentaries were what we now refer to as editions, with the obvious difference that they needed to be copied by hand, and the author of a commentary is perhaps better referred to as an editor. Diophantus, also known as the father of algebra, wrote a series of 13 books called Arithmetica. He was the first person to recognize fractions as numbers. His work deals with various algebraic equations. According to the Suda, one of the books may be based on Hypatia's commentary. Deacon stated that on this account the most likely of the supposed interpolations to have come from Hypatia's hand are 2 student exercises at the start of Book 2. The first asked for the solution of a pair of simultaneous equations where A, B are known. and the equations are x minus y equals a and x squared minus y squared equals x minus y plus b. The next exercise was similar to the first one, and it requires a solution of the pair of simultaneous equations where a, b, and m are known, and the equations are x minus y equals a and x squared minus y squared equals m, and then in parentheses x minus y plus b. The commentary by Hypatia included some alternative solutions and a number of new problems that she originated. Apollonius wrote about conic sections. Apollonius introduced the names ellipse, parabola, and hyperbola. For all three cases of conic sections, he showed this using a cone and introduced the fact that a cone has two halves. The Suda says that Hypatia made a commentary, and it is possible that Eutychius used it for his work. Hypatia's father Theon says she contributed to the third book of Almagest, which is one of the most influential texts of all time. The Almagest is an astronomical canon of Ptolemy that contained his numerous observations of the stars. Theon's commentary on Book 3 of Almagest proudly wrote of contribution of my daughter Hypatia the philosopher. According to Yelena Zabrak, Hypatia co-authored with her father at least one treatise on Euclid, and most of these works were prepared as textbooks for her students. Synesius wrote a letter stating that she contributed to the making of the astrolabe. According to Smith, the astrolabe is used to make measurements of position of celestial objects, the time, the season, altitude, and latitude. Another contribution included her invention of the hydrometer. The hydrometer is an instrument used to measure specific gravity or relative density of liquids, that is, the ratio of the density of the liquid to the density of the water. Her legacy and her work have been proven to be a great contribution for mathematics and an inspiration to women. Hypatia of Alexandria is connected to the ideas from Math 4110 course material and to modern-day mathematical ideas in multiple ways. As I stated earlier, during her time there was a shift from publication of original material to conservation of material. They sought to prove, collect, and teach the material of past mathematicians. Because of Hypatia, we have the work from Euclid, Apollonius, Diophantus, Ptolemy, and others. Some of the work of Euclid was addressed in Unit 3, which discussed the topic of early Greek mathematics. The Greeks had developed a lot of mathematics primarily related to geometry and number theory. There was a lot of work by Pythagoras and his followers about mathematical discoveries, along with Plato's philosophy and Aristotle's logic. A lot of the earlier proofs were disorganized and started from a variety of assumptions. A lot of the work was also very inconsistent. Euclid organized and expanded on the work of these great philosophers and mathematicians. Euclid's work was very important to the history of mathematics, and we are lucky to have the majority of his work thanks to the conservation of Hypatia and others. In Unit 3, we also discussed the idea of the Pythagorean theorem and Pythagorean triples. This work is related to the work of Diophantine and Euclid, which is one of the works that Hypatia made a commentary on. The work of the Pythagorean theorem was a popular topic of study throughout Greek culture. Throughout Unit 3, many Greek mathematicians are discussed, such as Euclid, Archimedes, Heron of Alexandria, and Ptolemy. Quoting from the text, all were tremendously influential in the later development of mathematics, and all raised interesting questions about the varieties of Greek mathematics which were competing for influence over the long historical period which concerns us. Some of the other mathematicians during this time were Apollonius, Diophantus, and Pappus. Although Diophantus and Apollonius were not discussed as much in Unit 3, they still made important discoveries during this time period, which I discussed throughout this presentation. Within Unit 3, there is a section on page 71 to 73 on Greeks practical and theoretical that describes the life of Hypatia. In this section, it describes Hypatia's life as a female philosopher and mathematician. It also describes how with many historical figures, much is known about their work, but little about their lives, and in Hypatia's case, it is the opposite. We have many accounts describing the life of Hypatia, but we have little proof of her actual mathematical work. In the same section in Unit 3, they quote, "Hypatia, a real, historically documented heroine, is a find for today's young adults who are searching for strong nonfiction role models." From examining Unit 3, it can be found that Hypatia was clearly very influential throughout Greek mathematics. Hypatia has also greatly influenced modern-day mathematics. Her work and contributions have become a popular topic of study. Historians still debate about specific aspects of her life and are continually making new discoveries about past events. She has greatly influenced many individuals of present day. She has been admired by women, scientists, and mathematicians. She has even had many movies, journals, and art galleries named after her. She has become an icon for females in the STEM community. There are many ways in which a secondary math teacher could incorporate ideas from the research focus into a high school classroom context. A secondary math teacher could incorporate the ideas of Hypatia's teachings of conic sections and Diophantine equations. The first example I will use is teaching conic sections. In geometry, a conic section is a curve created when one cuts through a cone with a flat plane. Mike Dehan explains, picture an empty ice cream cone with a point at one end and a circle at the other. In geometry, the nape of a cone is one of the two parts of a double cone. The complete cone looks like two ice cream cones attached at one point and extending infinitely far in opposite directions. The point of a cone is called the vertex or the apex. Dehan states, a cone often pictures one nape with a circular base on the flat horizontal plane, with the vertex above the base rather than below it. A right cone implies that the vertex is directly above the center of the base. If the vertex is not directly above the center of the base, the cone looks lopsided or tilted. The idea of conic sections can easily be shown by objects such as an ice cream cone. By cutting into the cone, you can show the idea of conic sections and have a fun interactive activity in the classroom. By cutting the cone parallel to the base of the cone, or perpendicular to the vertex, the result is a circle. When this cut is slightly tilted, the result becomes an ellipse. When the cut is parallel to one side of the cone, a parabola is the result. Finally, if the cone cuts through both napes of the double cone, the result is a hyperbola. The next teaching that can be used in the classroom is the principles of Diophantine equations. Hypatia taught various equations of Diophantine. One equation that everyone is familiar with and uses today is the Pythagorean theorem. In mathematics, the Pythagorean theorem is a fundamental theorem in Euclidean geometry among the three sides of a right triangle. It states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. The Pythagorean theorem means a squared plus b squared equals c squared, where a and b are the two shorter sides and C is the hypotenuse of the triangle. This formula is described to find the lengths of the sides of a right triangle and was also commonly used to find Pythagorean triples such as 3 squared plus 4 squared equals 5 squared. You can give word problems related to Diophantine equations to help students with their critical thinking skills. One example of a Diophantine riddle is, I am twice as old as my son, who is 6 times the age of his daughter. Next year, she will start school at age 6. This can be solved by setting up 3 different equations. The first equation is I equals 2 times S, which represents I am twice as old as my son. The second equation is X equals 6 times D, which means who is 6 times the age of his daughter. The last equation is D plus 1 equals 6, which means that next year she will start school at age 6. To solve the series of equations, we would first start with D plus 1 equals 6 and subtract 1 on both sides to find that D equals 5. Then we are able to substitute in the D equals 5 into the second equation, S equals 6 times D, which makes the equation X equals 6 times 5, which means S equals 30. Finally, we can substitute S into the first equation and get I equals 2S, which is I equals 2 times 30, which gives you I equals 60. Therefore, the daughter is 5, the son is 30, and the man is 60 years old. Another more difficult example is 2 farmers agree that pigs are worth $300 and goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats, with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs and 1 goat received in change. What is the amount of the smallest positive debt that can be resolved in this way? The choices for this problem are A, 5, B, 10, C, 30, D, 90, E, 210. This problem can be solved in multiple ways. The problem can be restated as an equation of the form 300p plus 210g equals x, where p is the number of pigs, g is the number of goats, and x is a positive debt. The problem asks us to find the lowest possible x value. P and g must be integers, which makes the equation a Diophantine equation. The Euclidean algorithm tells us that there are integer solutions to the Diophantine equation am plus bn equals c, where c is the greatest common divisor of a and b, and no solutions for any smaller c. Therefore, the answer is the greatest common divisor of 300 and 210, which is 30. Thus, the answer to this problem is C30. I think that all of these exercises would be great to incorporate in the classroom, particularly for algebra students. They would be great to use at the beginning of lessons, and I also think that they would be great extra credit assignments. You can find many similar problems on websites such as artofproblemsolving.com. These are just a few simple ways that one could incorporate Hypatia's teachings. A teacher can also use Hypatia as an example in the classroom to inspire female students to pursue a career in mathematics. I personally think that the story of Hypatia is very inspirational, and I am glad that I was able to learn about this topic and share it with others. I hope that you enjoyed learning about the historical content mathematical advances, connections to the units, and the ways a math teacher can incorporate the teachings of Hypatia into a high school classroom. Thanks for listening.